The so-called heat collecting elements, HCE, are the typical receiver tubes of parabolic trough collectors. These receiver tubes are placed at the focal line of the collectors so that the working fluid circulating inside these tubes is heated by the concentrated solar radiation, thus converting into thermal energy the concentrated solar radiation reflected by the parabolic mirrors. The receiver tubes are one of the key components of parabolic trough collectors because the overall efficiency of the collector depends on the efficiency of their receiver tubes. Since the maximum working temperature of parabolic trough collectors is within the range 400 to 500 degrees Celsius, the receiver tubes must be very efficient to reduce thermal losses at these temperatures. This is the reason why, from a technical standpoint, the receiver tubes of parabolic trough collectors for 400 to 500 degrees Celsius are quite sophisticated. A typical receiver tube is composed of two pipes, an inner steel pipe and a cylindrical glass cover. The steel pipe is made of stainless steel provided with a selective coating of high absorptivity, 95%, and very low emissivity, less than 10%, in order to absorb most of the concentrated solar radiation reflected by the parabolic mirror, while reducing the heat radiation losses to a minimum. Due to the selective coating, the color of the outer surface of the stainless steel pipe is dark blue. The glass cover is made of borosilicate glass, which is a special glass with a very low iron content in order to increase its transmissivity to solar radiation. The glass pipe is provided with an anti-reflective coating on both sides, thus achieving a solar transmissivity of about 96%. Due to the very different thermal expansion coefficient of stainless steel and glass, the glass cover and the inner steel pipe are connected at both ends using flexible bellows. These bellows avoid the breakage of the glass pipe when the receiver tube is heated up because the flexibility of the bellows will compensate the different expansion of the glass and the steel pipes. One end of each bellows is directly welded to the steel pipe, while the other end is connected to the glass cover by means of a glass-to-metal welding. Additionally, the bellows allow to have an airtight annular space between the steel and the glass pipes, so that a vacuum pump can be connected via a glass pin to make a high vacuum in the annular space between both pipes to avoid conduction and convection heat losses. Another peculiarity of these receiver tubes are the getters, which are small circular pieces made of alloys with the property to absorb gases. These getters are used to absorb molecules of gases that may enter the annular space between the steel and glass tubes during the lifetime of the receiver. These gases would destroy the vacuum and the thermal losses would significantly increase, thus reducing the efficiency of the receiver tube. A typical receiver tube is also provided with a vacuum indicator, which is a barium hotspot deposited at the inner side of the glass pipe. Barium quickly reacts with the oxygen of the air to form barium oxide, which is white. That way, the color of the barium spot shows the status of the vacuum inside the annular space. A gray color indicates that the vacuum has not been lost, while a white color indicates that there is air in the annular space and therefore the vacuum has been lost, at least partially. In conclusion, the receiver tube of parabolic trough collectors are sophisticated components that can convert concentrated solar radiation into thermal energy with a high efficiency. This technical complexity imposes a high price of this element. These receiver tubes may be used in linear Fresnel concentrators too.